Hey everyone, welcome to another 6th grade Jump Math lesson. Today's lesson is Statistics and Probability, Lesson 4, Dot Plots. Our goal in this lesson is to be able to create and interpret dot plots and calculate their mean and their median. We're going to be using vocabulary we're already familiar with, such as data points, line plot, and symmetry. We're also going to be introducing the new term, dot plot. This diagram here shows a set of 5 data points. What are the 5 data points? Well, we have a stack of 8, a stack of 8, another stack of 8, a stack of 5, and a stack of 2. So these are our 5 data points. When we have large sets of data, these diagrams are not going to be very useful. Like if we had a set with 100 data points, we would have to actually draw 100 stack of beads. And if there was a large set of data that had repeating data points, like if there were 28s, well, we would have to draw 20 stacks of 8 beads. That's a lot of beads to draw just to show the 8s in the set. So we need a type of diagram where we can draw one symbol, like a dot, for every data point in the set. And this graph is going to be called a dot plot. Here's an example of a dot plot. A dot plot has 4 major elements. The first is a title, and the title is telling me what the entire dot plot is representing. Our second thing is going to be a number line. The number line has to be consistent. So in this case, they have a gap of 1 between 1 and 2. So they maintain a gap of 1 as they continue counted. They could have chose a gap of 5, but again, they'd have to keep it consistent. The third element is label. This label here is telling me what my number line represents. So this label is telling me what my number line represents. So number of stories is our label. So that means this is people who wrote 1 story. This is people who wrote 2 stories. This over here is people who wrote 6 stories. It's telling me my number of stories. And then the fourth and final element to a dot plot are the dots themselves. And the dots are the participants in the survey. So in this case, we're talking about students who wrote a story. So each of these dots represents a story a student wrote. So now we're going to be able to interpret from a dot plot by reading these 4 elements. So when it asks, what is a dot plot about? I know I need to look for the first thing, the title. And this dot plot is about the number of stories each student wrote, because the title tells me what my dot plot's about. How many students wrote 1 story? To figure this out, I need to go to the number of stories that say 1, in this case here. And it looks like there are 1, 2, 3, 4, 5, 6, 7, 8 students who wrote 1 story. So same graph, but just different questions. Now they want to know, what was the largest number of stories any student wrote? Well, the number of stories is the number line, and the largest amount is 6, because that's as far as our dot plot goes. So the largest number of stories any student wrote was 6. How many more students wrote 1 story than 2? So how many more students wrote 1 story than 2? So right now we're only using the 1 story and the 2 story stacks. We're not looking at the rest. And they want to know how many more wrote 1 than 2. So I go to the top of 2 and then I count the difference. It looks like 1 story has 2 more data points. So 2 more students wrote 1 story than they did 2 stories. How many students wrote either 5 or 6 stories? So in this case, I only want to look at the 5 and the 6. And it says or, which means I need to total both of them, because as long as they fall in one of the categories, it'll count. So in this case, there are 2 on the 5 and 2 on the 6. So my answer is 4. Now we're going to make our own dot plot using the data from the chart. So they give us a chart. They've already done our title. They did our number line. And they did our label. All we're responsible for right now are the dots. So we're going to use the frequency in order to get the dots. Ooh, I put don't, not dots. I don't know why. So number of plums picked, 1 has a frequency of 5. So I'll put 1, 2, 3, 4, 5 dots. As neat as possible. 2 has a frequency of 4, so 1, 2, 3, 4. 3 has a frequency of 2. 4 has no frequency, and 5 has a frequency of 3. Now that we have our dot plot, we can answer questions by reviewing it. So how many people picked 1 plum? 5 people. Because there's 1, 2, 3, 4, 5 dots above 1. How many people picked 3 or more plums? So we're only going to look at 3 or more. 1, 2, 3, 4, 5. What was the largest number of plums any person picked? Well, these are my number of plums, and the largest value we have is 5. Did anyone pick exactly 4 plums? There are no dots above 4, so our answer is no. How many more people picked 1 plum than 5 plums? So we're only looking at 1 and 5 right now. And 1 has 5 plums, 5 people who picked plums, and 5 has 3 people who picked that many plums. So there is a difference of 2. So 2 more people picked 1 plum than 5 plums. Altogether, how many people picked plums? So altogether, that means they want me to count every single dot on my data point. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14. In this case, you can count the dots, or you could have added up the frequency. This is 5 plus 4, which is 9, 9 plus 2, which is 11, and 11 plus 3, which is 14. 2 different strategies. Good way to double check yourself. Sometimes you'll see plots that look like dot plots, but they're really not. For instance, B and C are not dot plots. So let's just compare them with A, who is a dot plot, and see what's different. Comparing A and B, the difference is that B does not have a number line. You have to have a number line to be a dot plot. So since it has words instead of numbers, B is not a dot plot. What about A and C? Well, C does have a number line, but if you look between the numbers, their gap is inconsistent. From 10 to 11 is plus 1, but 11 to 13 is plus 2, and 13 to 17 is plus 4, and 7 to 18 is plus 1. This is not a consistent rhythm. You have to have a consistent way of counting. It can vary, but once you make a decision between your first 2 values, it has to continue throughout all your values. So C does not count consistently. So it is not a dot plot. So all dot plots must have a number line at the bottom, and to be a number line, the gaps all have to be the same. A plot without a number line is not a dot plot. Here we have a dot plot, and just as we create dot plots from tally charts, we can create tally charts from dot plots. So for our data values, we'll count from the lowest to the largest, including even those without a dot. So we've got 1003, 1004, 1005, 1006, 1007, and 1008. Now we're tally. In this case, every tally is a dot on the graph. So 1003 has 4 dots, so 4 tallies. 1004 has 2 tallies. 1005 has none. 1006 has 1. 1007 has 5. And 1008 has 3. And now we can complete the frequencies. This is 4, 2, 0, 1, 5, and 3. Recall that a shape is symmetrical if you're able to fold it along a line of symmetry and the sides fit exactly over one another. Here we have a data table of tally chart of a symmetrical data set. I know this because the outmost values, so the lowest and the highest, have an equal number of frequency. And as I move inward, the next highest and the next lowest also have an equal frequency. And then you have a value in the middle. In this case, it has no frequency. So this balance means if I were to fold my table, they would be exactly equal on both sides, like a reflection. So they want us to find the total and the mean using our frequency. So using our frequency, we've got the total. So 10 times 3 is 30, plus 11 times 2 is 22, plus 12 times 0 is 0, 13 times 2 is 26, plus 14 times 3 is, that one I don't know off the top of my head, 42. Now we add it. The best way to add this is to stack them up. So we got 30 plus 22 is 52, plus 26 is 78, plus 42 is 120. And we'll divide it by the number of data points in our data set. The way we do this is by adding our frequencies, because that's going to tell us how many numbers there were. There were 3 10s, plus 2 11s, plus 0 12s, plus 2 13s, plus 3 14s. So 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 3 is 10. So we're going to divide by 10, and our mean is 12. So what would the median be? Well, the median is your value in the middle. In this case, if I were to go from the outside in, crossing the same amount, here are 3 data points I crossed out, so 3 data points. I crossed out another 2 data points, another 2 data points. And so my middle 2 data points would have been 11 and 13. And the number between 11 and 13 is actually 12. What do you notice about the mean and the median? Well, they're both equal. In symmetrical data sets, the median and the mean are always equal. So now it's time for you to try. Pause the video here, and I want you to put the data in a chart. Look at the arrangements of the tallies, and then decide if the mean will equal the median. When you're ready, play the video, and we'll go over the answers together. All right, let's start with A, and I may have to do some scrolling around because there's not a lot of space. So for A, here are my data values, my tally, and my frequency. My lowest one is 26. My highest is 29. So we got 26, 27, 28, and 29. Now we're ready for my tallies. 27, 26, 27, 26, 26, 29, 28, 28. And now my frequencies. 3, 2, 2, and 1. So looking at this data chart, right off the bat, it is not symmetrical. Since it's not symmetrical, I know that my mean and median are not going to be equal. Let's try the next one. I'll just clear this out, and we'll do B. So again, I need 3 tally charts. 3 sections. Data value, tally, and frequency. We got all the way from 9 to 15. So 9, 10, 11, 12, 13, 14, 15. Tallies, 9, 13, 15, 9, 12, 15, 12, 9, 11, and 15. And now we're ready for frequencies. 3, 0, 1, 2, 1, 0, 3. So looking at these, working from the outside in, I can do 3 from the max, 3 from the min. Meaning my largest value has 3 and my smallest values have 3. Going inward, 0 and 0, so it's still balanced. Continuing to go inward, 1 and 1. So that means that this is a symmetrical data set because this right here is my center point and it's completely the same on both sides. So we had no for A, but yes, the mean and the median will be equal on B. Let's do C. So we got a no and a yes so far. 3 columns, data value, tally, and frequency. We've got all the way from 2 to 11, so 2, 3, 4, 5, 6, 7, 8, 9. I'm going to need some more room. So I need to extend these lines. 10 and 11. Now we can do frequencies. We've got 2, 7, 9, 5, 7, 11, 7, 11, 7, 2. And we can do our frequencies. 2, 0, 0, 1, 0, 4, 0, 1, 0, 2. So working on the outside going in, my minimum is 2, my maximum is 2. So far balanced. The next one's 0 and 0, balanced. The next one's 0 and 1. This is not balanced. So since this is not symmetrical, no, my mean and median will not be the same. So we got no, yes, and no. Now let's try our bonus. Trying to get me some room. Data values, tallies, and frequency. Looks like our lowest one is 140, and my highest one is no, I'm sorry. My lowest one is 100, my highest one is 160. So we'll do 100, and then we'll count by 10. So 110, 120, 130, 140, 150, and 160. Okay? So we've got to do our tallies next. So we got 160, 160, 140, 140, and 60, 160. So filling out our frequencies, we've got 1, 0, 0, 0, 2, 0, 4. And right off the bat, the minimum and the maximum are not balanced. So no, this will not have the same mean and median because it's not symmetrical. You can find the mean of a symmetrical data plot just by finding the center value. But for dot plots that aren't symmetrical, you're going to have to calculate the mean. So in this case, it's not symmetrical. So the way we calculate it is we add up our values. We have 1, 2, 3, 4, 5 ones, so 5 times 1, plus 3 times 1, plus 6 times 1. So we end up with 5 plus 3 plus 6. 5 plus 3 is 8, plus 6 is 14. Now, that's our total. We have to take our total and divide it by the number in our data set. So we'll go back and count how many dots we have. 1, 2, 3, 4, 5, 6, 7. So 14 divided by 7 is 2. So my mean is 2. Can we tell what the mean and median are going to be when we look at the dot plots A and B? No, because there's no numbers on our number line. I have no idea what those dots are representing. They could be 1, 2, and 3. They could be 1 million, 2 million, 3 million. We have no idea. But can we tell if the mean and median of dot plot A will be the same? Yes, the mean and median for A will be the same because the dot plot is symmetrical. What about for B? Also yes, because that dot plot is also symmetrical. When they're symmetrical, we can guarantee the mean and median will be equal. What are the mean and median A if we add some data points? So look, this one, it was meant to be 5, 10, and 15. And this one was meant to be 30, 60, and 90. So what would the mean and the median of A be? It would be 10. And the mean and median of B would be 60. Because that is my center value. Now without calculating, try to answer these 3 questions. When you're ready, play the video and we'll go over the answers together. All right. So what the mean and median at A will be and if they will be equal. Well, A is symmetrical. So yes, automatically we know they'll be equal. And since they're symmetrical, it'll be in the center, which is 40 for the mean and 40 for the median. Let's also figure out whether the mean of A will be equal to the mean of B. Well, this one's no, because the center of the data for A is 40, but the center of the data for B is 50, so they're not equal. What about whether the median of A will equal the median of B? Again, no. The center value of A is 40, and the center value of B is 50. Those are not equal. Can we tell what the means and medians are going to be of these data sets? Again, no. And we can't tell it because there are no numbers. Can we tell if the mean and median of the dot plot A will be the same? And again, the answer is no, because A is not symmetrical. So since it's not symmetrical, I can't guarantee they're going to be equal. So now let's actually calculate the mean of A. So this is 1 times 1 plus 3 times 1 plus 4 times 2. So 1 plus 3 plus 8. 1 plus 3 is 4, plus 8 is 12. Now let's take that total 12 and divide it by our data points. We have 1, 2, 3, 4. So our mean is 3. This right here is my mean. Now if you notice, B is a dot plot that is set up almost exactly the same as A. The only difference are the values on the number line. But since we've already calculated A and proven that the 3 is going to be the mean for A, we can actually assume the mean for B will follow the same trend without having to calculate it. Our mean for B is 40. Because all we're changing in the numbers we're working with, but the balance is still the same, so the center will be the same. Now let's try to calculate C and see if it'll help us predict D, because C and D are drawn the same. So C is going to be 50 times 2. I did not like 50. 50 times 2 plus 60 times 1 plus 80 times 1. Oopsie, I forgot to put them in. Talking and writing at the same time. Not good multitasker. So I'm going to have to go down a little bit to continue working. But 50 times 2 is 100 plus 60 plus 80. This is 160 plus 80, so we got 240. Now we got to take our total, 240, and divide it by our data points. We got 1, 2, 3, 4. 24 divided by 4 is 6. And then we have 1, 0, so we'll put 1, 0. So our mean for C is 60. That's right here. So again, we won't have to calculate D since we've already calculated C. It'll follow the exact same trend. It just has different values, but the center is in the same location. So our mean for D is 9. You're now ready to move on to the AP book. I hope you enjoyed this lesson, and I'm glad you joined me for it, and I hope to see you in future lessons. Have a good day.